All right, so we have a review sheet here, and we have several questions that we need to answer. So I'll start answering the questions now. It says, describe and determine how you would discover the specific gravity of an unknown mineral given the information below. So the mass of the mineral is 80 grams, and it says that the water was 30 milliliters in the graduated cylinder, and then the mineral got put in, and it went to 50. So we know the difference between 50 and 30 is 20. So we have 20 milliliters of displaced water. Now, we know that in order to find, and they just said find the specific gravity of the mineral, so specific gravity is going to be equal to the mass of the mineral. So in this case, the mass of the mineral is 80 grams. So if you displace 20 milliliters of water, that's 20 centimeters cubed in terms of volume, and that's 20 grams of water. So we're going to take the mass of the mineral and divide by the mass of an equal volume of water, and 20, 40, 60, 80, so we have 4. So the specific gravity of this mineral is 4. Describe any 3 ways to distinguish between the minerals calcite and halite. Well, halite is a cube. Calcite is a rhombus. Halite tastes like salt. Calcite reacts with hydrochloric acid to produce carbon dioxide gas. If you look through the calcite crystal, you will see double. So calcite exhibits double refraction. So we have double refraction, we have a rhombus shape, and we have a cube shaped, and we have taste like salt. Pretty much that's it. We could say that because this is cubic, it has 3 directions of cleavage that meet at 90 degrees, whereas where this is a rhombus, there's 3 directions of cleavage, but they don't meet at 90 degrees. But there are some ways that these 2 minerals are different from each other. In terms of the uses of the following minerals, well, barite is used for drilling mud. Bauxite is an ore of aluminum. Pyrite is an ore of iron. Galena is an ore of lead. Quartz is used to make glass products. Chalcopyrite is an ore of copper. So, for example, copper wiring. Graphite is used as a pencil lead lubricant. Native gold is used predominantly as jewelry. It is used in some electronic devices as well. Magnetite, the biggest use would be magnets. Sphalerite is an ore of zinc, and zinc is used for stainless steel production. Hematite is an ore of iron, and feldspar is mostly just used for building materials. Distinguish between the terms mineral and rock. Well, a mineral is something that is inorganic, solid, naturally occurring, has a definite chemical composition and a definite structure. I need to give an example of each for this question. So my example of a mineral will be galena. A rock is also solid. It is also naturally occurring. A rock, though, can be organic or inorganic. So that is one vital difference. And a rock, by definition, is a mixture of minerals. The example of the rock that I will choose is a rock called gabbro. Why would coal, oil, gas, synthetic diamonds, and ice qualify as minerals? Explain why or why not. So we'll start out and we'll talk about coal. Coal fails as being a mineral because it's made of plant material, and a mineral has to be inorganic. Oil and gas I'll do together. Both are liquid or gas, and the definition of a mineral says it needs to be solid. Oil comes from microscopic animals, and gas comes from microscopic plants. So it also fails in that neither of these two are inorganic. Synthetic diamonds also fails being a mineral because synthetic diamonds are made by humans, and the definition of a mineral says that it needs to be naturally occurring. Ice is a little bit of a different one because ice do have a chemical structure. It does have a chemical composition. Ice is solid, and ice is naturally occurring, and ice is inorganic. So based on the criteria to describe a mineral or define a mineral, ice would qualify. Moving ahead, which chemical formula is matched with its mineral group? Well, when we look at this one, we see an S and an O, so that tells me right away that that belongs to the sulfates. Here we see a metal with sulfur, so we know that that's a sulfide. Here we see a metal with a group 17 element, so that is a halide, and there is no halide here. And this one here is silicon and oxygen. This is a silicate, and there is no silicate there. So a little bit of an error on my part here, because all we were supposed to do is to see which formula is matched with its mineral group. So this is not a match, and this is not a match, but this is clearly a match. So the answer is B, and this is not a match. So the answer is B. Moving on to the next question. A geologist has discovered a mineral, and the mass of the mineral is 85 grams. And so when that mineral got put in water, it says we had a volume of 19.1 milliliters. So 19.1 milliliters is equivalent to 19.1 centimeters cubed of volume, and is also equivalent to 19.1 grams of water. So what we're going to do is we're going to take the 85 grams in air and divide by the 19.1 grams of displaced water, and we're going to come up with a value of 4.45, telling us that the mineral that we are dealing with here is barite. Which is the least reliable indicator of a mineral's identity. So naturally we're going to look for color or luster, and we'll see that color is there, so the answer is B. Moving on. Which formula is correctly matched to its mineral group? Well, when I look at this, I see S and O. S and O means sulfate, and there it is. So right away it looks like A is the right answer. This is not a carbonate, this is an oxide, and this is a sulfide. So those three are all wrong. To which group does Ca2Al2SiO7 belong? When I look at this, I see Si and O, so that tells me that that is a silicate mineral, so the answer is C. On to the next question. What are the 8 most abundant elements in the Earth's crust? Key word in this particular question is crust. So automatically we think about the Great 8, Alexander Ovechkin, and the top 8 elements are Ottawa Senators are insane, Calgary should play Montreal. So Ottawa stands for oxygen, Senator stands for silicon, R stands for aluminum, insane stands for iron, Calgary stands for calcium, should sodium, play potassium, Montreal magnesium. And last page. What is the framework of the silicate mineral group? The answer to this question is the silicon, oxygen, tetrahedron. And if you were to look at a silicon oxygen tetrahedron, you have your silicon here, you have an oxygen in the same plane, an oxygen in the same plane, an oxygen coming out straight at you, so we use like a triangle effect, and a dotted line for an oxygen going back into the board. So that is a 2-dimensional representation of a 3-dimensional silicon oxygen tetrahedron. Remember, there's 4 oxygen for every 1 silicon because of Ottawa Senators. So Ottawa stands for oxygen at 46.6%, and Senator stands for silicon at 27.7%. Moving on, what are the rules for these mineral groups? So for oxides, we're looking for a metal plus oxygen. For sulfates, you're simply going to look for an S and an O. And if you remember from Science 1206, essentially what you're looking for is the SO42 negative polyatomic ion. For carbonates, you're looking for carbon with an O, and so you're really looking for a CO32 negative polyatomic ion. And for the halides, you're looking for a metal plus a group 17 element. So one of the elements in group 17. And I think that is it.